Hello everyone, this is Sir John. Welcome to my YouTube channel. In my previous video, I discussed to you about multiplying rational algebraic expressions. This time, we will talk about dividing rational algebraic expressions. In this lesson, you need to remember the ways of multiplying rational algebraic expressions. Okay, so let's start this lesson by dividing simple fractions. Okay, so I have here 2/5 divided by 2/3. In dividing fractions, we need to copy first the first fraction, 2/5. Then take the reciprocal of the second fraction, 2/3. Reciprocal of these 2/3 is 3/2. To write its reciprocal, the numerator becomes denominator and the denominator becomes the numerator. Then from division operation, we will proceed now to multiplication. Okay, so again, you will copy the first fraction, 2/5, then take the reciprocal of the second fraction, then from division operation, we will proceed to multiplication. That is why we need to remember the ways of multiplying rational algebraic expressions, because it is useful in this lesson. Okay, we have to cancel out or to cross out all the common factors that we can have in our problem. So in this case, in our example, we have 2 in the numerator and 2 in the denominator. So this can be crossed out. The greatest common factor of 2 is 2. So we will divide this 2 by 2 equals 1. 2 divided by the GCF 2 is equal to 1. Okay, so there's no more numbers that we can reduce to lowest terms. So we have to multiply now the numbers. 1 times 3 is 3 over 5 times 1 is 5. So this is now the answer. When you divide 2/5 by 2/3, the answer is 3/5. Let's have another example. We have 5/7 divided by 10/21. Again, we will copy the first fraction, 5/7, then reciprocate the second fraction. We have 21/10. From division, proceed to multiplication. So we will find numbers in the numerator and denominator which have common factors so that we can reduce it to lowest terms. 5 times 21 is a big number, so let's check if we can reduce this to lowest terms. 5 and 10, in the numerator 5 and in the denominator 10, we can reduce this one by the GCF. Okay, so the GCF of 5 and 10 is 5, so we will divide this 5 by the GCF 5, that is equal to 1. 10 divided by the GCF 5 is equal to 2. Then as we can see, 7 and 21 can be reduced by dividing the GCF 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So we now have new numbers in the numerator, 1 and 3, and then in the denominator we have 1 and 2. So we will multiply now the numerators. 1 times 3 is 3. In the denominator, 1 times 2 is 2. So this is now the answer, or we can have 1 and 1/2. Okay, so let's try this example. At this time, we have variables in the rational algebraic expressions. So 4x over y squared divided by 6x squared over y. As you can see, our numerators are all monomials and also our denominators are all monomials. So first step, we have to copy first rational algebraic expression. We have 4x over y squared. All right, so let's reciprocate the second expression, that is y over 6x squared. Okay, from division proceed to multiplication. It is very important that you have to reciprocate first the second expression before you proceeding to multiplication. Okay, so with this, let's find numbers that can be reduced. We have 4 and 6, numerator versus denominator. 4 and 6, the greatest common factor of these numbers is 2. So we will divide this 4 by 2, that is 2. 6 divided by the greatest common factor, 2, that is equal to 3. With the variables, we have x and x squared here. X squared means x times x. So we will cross out 1x with this 1x, remaining is 1x. And then y squared is y times y. So we will cross out 1y. So this one, the remaining is 1y, and this one becomes 1. Okay. Now we have 2, 1, y, 3x. So we will multiply now the numerators. We have 2 times 1 is 2 over y times 3x y times 3x. Okay, so let's simplify. We have 2, multiply it, y and 3x. Y times 3x is 3x y. So this is now the answer. Alright, let's have another example. This one. We have x squared minus 4 all over x minus 3 divided by x plus 2 all over x minus 3. So we will copy first the first expression, this rational algebraic expression. We have x squared minus 4, then x minus 3. Then we will proceed to multiplication if we will reciprocate this one. And the reciprocal of that is x minus 3, x plus 2. Okay. Now, make sure that all expressions in the numerators and denominators are factored out. In this example, x squared minus 4 can be factored. This is a difference of 2 squares. So we will factor this first before canceling the common factors. So let's find its factors. We have x plus 2. The other one is x minus 2. Okay, these are the factors of x squared minus 4. Then copy x minus 3 because this is not factorable. The x minus 3 also, it can't be factored. X plus 2 as well. Okay, so with this, since we already factored all the polynomials in our expression, So we can have cancellation of common factors. We will cross this out, x plus 2 with this x plus 2 in the denominator, this x minus 3 in the denominator, and x minus 3 in the numerator. So this becomes 1 1 1, and this one is 1. Okay, so we have 1 times x minus 2 is x minus 2 over this one is 1 times 1 over 1. Let's continue here. X minus 2 times 1 is x minus 2. 1 times 1 is over 1, or simply we will not write 1 in the denominator. It's understood that it is x minus 2 is our answer. Okay, so let's proceed to another example so that you can learn about this dividing rational algebra expressions. Okay, so we have 2x squared plus 4x plus 2 all over x plus 1 divided by 2 over x. This can be factored, this cannot be factored anymore, this cannot be factored also, and as well as this expression. So we will factor this out. But before that, again, let's copy this first before factoring the expressions once we proceed to multiplication process. So this is x over 2. Okay, reciprocal of this. Now, if we have already in multiplying rational algebraic expressions or in the process of multiplication, we will factor all expressions that can be factored. So, as you can see, this can be factored with the use of greatest common monomial factor. I have video on that. You can check it on my YouTube channel. The videos on how to factor polynomials. So this one we can factor out 2. Then the other factors, we have x squared plus 2x plus 1. Alright, to check, 2 times x squared is 2x squared, 2 times positive 2x is positive 4x, 2 times 1 is positive 2. Okay, so we are correct with our factors. Then copy non-factorable expressions. Okay, we are not yet done with this factoring. We have x squared plus 2x plus 1 can still be factored. We have to factor this. This is a perfect square trinomial. I have also a video on how to factor perfect square trinomial. So we have two binomial factors, x plus 1 and x plus 1. So x plus 1 and x plus 1 are the factors of this trinomial. Then the 2, we just copy it here. Then proceed to copying other expressions to complete our sentence. Now we will do cancellation of the common factors. Or we can cancel 2 in the numerator and we can cancel 2 in the denominator. So this becomes 1 and 1. Now we can also cross out this x plus 1 with this x plus 1. Numerator, denominator. Okay. So since there's no more, we have to continue multiplying them. So we have 1 here and 1 here. 1 times x plus 1 is x plus 1. Alright. Then all over 1 here, then multiply, then copy x, and we have 1. Alright. So we have to multiply now the numerators, x plus 1 times x we have x times x plus 1. I usually write monomial so as not to confuse my students, so I write the monomial first before the binomial and other polynomials. Then 1 times 1 is 1, so we don't need to write all over 1 or over 1 here, because it's still the answer is x times x plus 1. But we have to simplify this. By distributive property, we will multiply x to x, the answer is x squared, then x times positive 1 is positive 1x. Okay, so we don't need to write 1 here, because it's understood that if there's no numerical coefficient here written like 2, 3, 4 and so on, it's understood that it's 1. Okay, so this is now the answer in this problem. Alright, so let's have one more example. Okay, so x squared plus 6x plus 9 all over x squared plus 3x plus 2 divided by x plus 3 all over x plus 2. Okay, so we have trinomials and binomial. Again, we have to copy first the expression, the whole expression, the first expression given, rational algebraic expression, x squared plus 6x plus 9 all over x squared plus 3x plus 2. Alright, then we will have its reciprocal. We have x plus 2 over x plus 3. From division, proceed to multiplication process. Okay, after we have in our multiplication, we will now factor all the expressions that can be factored. So x squared plus 6x plus 9 is a perfect squared trinomial, so we have two binomial factors. We have x plus 3, the other one is the same, x plus 3. Oops, okay. Then we will also factor x squared plus 3x plus 2. This is not a perfect squared trinomial, this is a general quadratic trinomial. So let's factor this. We have x, another x, so we have plus 2, this one is plus 1. Okay, so x plus 3 and x plus 3 are the factors of this trinomial. X plus 2 and x plus 1 are the factors of this trinomial. Alright, so we will continue copying these expressions which cannot be factored. This one, x plus 2 all over x plus 3. Now, all polynomials were factored, so we can do cancellation of common factors. We can cancel this x plus 3 in the numerator with x plus 3 in the denominator, so this becomes 1 and 1. Alright, next we can cancel also x plus 2 and x plus 2 here, the denominator and in the numerator, so this one becomes 1 and this one becomes 1. Okay, what else? None. Okay, so if none, we will copy the remaining factors. So 1 times x plus 3 is x plus 3 over 1 times x plus 1 is x plus 1. Okay, times 1 over 1. Okay, so 1 over 1 is 1. So that x plus 3 times 1 is x plus 3 all over x plus 1 times 1 is x plus 1. Alright, so this is now the answer. Okay, that's it. That's how to divide rational algebraic expressions. Remember, in dividing rational algebraic expressions, you need to remember all the ways in factoring polynomials. We have factoring polynomials with the greatest common monomial factor. You can also factor polynomial that is a difference of two squares, that is a sum and difference of two cubes, general trinomial, and a perfect square trinomial. If you want to know about this, you will check my, or you have to visit my YouTube channel, Aha Mathdali, to check all my videos about factoring polynomials. I think that's all for today. I hope you learned something from my discussion. If you like this video, click like. If you want others know about this, you may share this video to others. And please don't forget to subscribe to my YouTube channel and hit the notification bell for you to be updated of my upcoming videos. Alright, until next time, goodbye everyone.